Okay, so you can see the homework. So this is what was on Canvas, except it didn't have this top line. So I just said this assignment is for each student, but cooperating is acceptable. So that gives you permission to work together on this, but you each have to turn in the assignment. So there are 4 problems here. This one says determine the upper and lower control limits for both the mean and the range charts. And so that's the A part. And then calculate the X bar and the R bar, and then the upper and lower control limits for the R. So you want to do the mean and the range in that. And then number 2, there's 5 observations. Here's the table. So the mean and the range is calculated, and then you need to do the upper and lower control limits for the mean and the range in there. So you might have to draw some of these control charts on the paper to do that. Here's number 3. There's 4 samples there. And then the P charts. And I've got another example of P chart for you, so I think that'll be a little clearer. And you need the, let's see, the Z value. I just give you the Z value, does it? Well, okay, so I just put that up there, and I'm going to take this out. This, yeah. This is going to be Z. So you need the Z chart, the Z value, and I'll show you that in just a second. Control limits. C times 9. And then this should not have this in it. There. Okay. Oh. This should not be here. Yeah, because you need 5 values. Okay. I don't know how that got like that. Okay, so that's what's in there. So that's now posted. Let me stop this and let me go back and show you the P example. I found another one because I didn't have the Z value in there in that one. I don't know what happened to that. It must have, it got changed somehow. So stop sharing. Okay, so let me share this.
Eighty percent that 5:45.
Able to get his hands on the rebound, and he will earn a trip to the. It was nice.
Okay, you can see this, right? So here's the P example. So this has the numbers in it, the numbers of defects and the number in each sample. So you add the total number of defects up and you get 9. The total sample size is 100. So for the control limit, you calculate the P bar, which is going to be the 9 out of 100, which is going to be the 0.09. So then you have P bar times 1 minus P bar. So it's going to be 0.09 times 0.91. And then you're going to divide that by 20 because that's the number of samples that you have. N is 20. The N is the number in each sample. So that's 20. So you need the samples to be the same size. Then you take the square root of that, and that's going to give you 0.64. Then to calculate the control limits, you need this Z value, which is given to you. So you take the P bar, which is the 0.09, plus Z, which is 3, times the standard deviation, which we just calculated is 0.064. So 3 times 0.064 plus 09 is going to give us 0.282. And then for the lower control limit, it's going to be the 0.09 still, but it's going to be minus the 3 times 0.064. And when in this case, when we do that math, it's going to be a negative number. So then the lower control limit becomes 0. Because you don't have negative control limits. You don't take negative values when you're sampling the size. So the lower control limit is 0. So you just plot that out. But you need the Z value there. And then you need to, the sample size is 20. So I think on this one, I used 800 and it should be 100, which would then be over 100. Which is going to be 02. And then where would it? No, not 02.2. 0.2 times.
Isn't it also divided by 200 instead of divided by 4? Since N is 200.
I'm sorry, which one, Ivana?
The one that you're in right now, the standard deviation, N is 200, not 4.
This one is the total number of observations. But the standard deviation.
It's N at the bottom, right? And it isn't N 200, N equals 200 at the top.
Let's try that.
And you still want the divided by, I think.
Oh, thank you. Yeah. 4. There's something still wrong with this one. But this one is right. So we take the P bar, 9 divided by 100. The total 9 divided by the 100 is 0.09. Then we take 0.09 times 0.91 divided by 20, which is the number in the sample size. So you're right, that should be 200. So this should be
Also, your 800, I think, is correct too.
This is 1.2. Okay, so
Your original 800 over the total number of observations, I think. No, actually, no, never mind.
so this, I think this is 2 over the total observations. If
Yeah.
I look at this one, effects over the total inspected. No, total inspected is 100. So let's go back and put that to 800.
Oh, then total inspected is 800. Yeah.
So then this is going to be 20 divided by 800, which is going to be that 0.025. Then we take 0.025, 1 minus 0.2. And I couldn't find the source of where I was taking this from. I was looking at it, divided by 200. There we go. That's it. But then we need the Z to calculate the limits. And I don't have the Z for this one, but we could make one up and we could say if we have the P bar, it's 0.025. If Z is equal, let's just say Z is equal to 3. So then we take the 0.025. We don't want the parentheses there. Plus 3 times the sigma, which is going to be 0.011. And then this is going to be minus. So then it's going to equal 0 because we can't have the negative number. Yeah, thank you. So I'm sorry if I made that really confusing, but hopefully with the math in here, you can see that. This is going to be the 20, which is this number here, times the total number of errors. It's the total number of errors. We're going to divide by the total number of observations, which is 800. That's up here. And we know that because each sample size is 200. That gives us the 0.025. The 0.025 times 1 minus 0.025, and then we're going to divide by 200, which is the number in the sample, and then we're going to take the square root of that, and that's going to be the 0.011. So this has the answer in it too. So, but that's okay. And then here's the upper and lower control limits, and then here's another example of that. So let me save this and stop sharing, and I will put that in. I'm going to put this version in the in Canvas. Okay. So the assignment's in there and the example worksheet is in there. And I think, Latoya, you were asking me to put both of them in there. They're just on different sheets. So does that cover what you wanted? Both samples. Okay, good. All right. Okay, so the Six Sigma, you can take a whole 16-week class on Six Sigma and just doing these control limits and understanding the different variations and the different curves and things like that. So it's way more than statistics, but I don't, I have 8 weeks and 3 classes and 8 classes to teach you some of this stuff. So we can't cover all of that in that much time. So hopefully that's enough of the basics. You'll get to calculate a couple of the charts. And then we can go from there. And yes, anybody that came late, I get your attendance, and I always go back and look at the reports too from Zoom to do that, because I can do that. But I think I told you the first day I take roll, because even though I can't get most of you to turn on your cameras and so I can see your beautiful faces, I like to try to get to know, put names and faces together and connect with people. So,
Professor,
yes.
are you ever going to have a class like that where you give a 16-week course talking about the calculations and the different graphs and all?
Am I going to do that?
Yeah.
Not necessarily. I do a Lean and Six Sigma class, I'm kind of updating all of that, probably for the, I don't know, March, April, May kind of time frame. But I could make it heavier in statistics. That's just, I just don't have that all put together. But you can take programs. I mean, you can take courses for getting your green belt, black belt. Unless you have a lot of background in statistics, I would say get your green belt first if you're interested in doing that. And there are programs you can take. I think there's one through Cal State Fullerton through the extension program. Dominguez Hills might have one. I'm not sure where else they have those programs, but a lot of times colleges will do it like at the community college level. Santa Monica does not. They don't have a green belt or any other kind of program. Yellow belts and white belts typically are given through a company, and you get them through the company's program. They put their own programs together, and they're not accepted widely. Green belt programs and black belt programs are accepted, around the world. If you have a green belt from an accredited place, and you can get them online. If you are so inclined to do that. So you guys are obviously comfortable with online classes. It's harder material, I think, to learn online than if you could get somebody in live to do it. But they do have those programs.
Do you need a yellow belt to get a green belt?
No.
Okay.
You can go in cold, Peter, and get a green belt. And you can get a green belt with never having taken a statistics class. It's going to be easier for you if you have taken some basic statistics.
Mm-hmm.
But if you're willing to do the work and maybe do a little background kind of thing on your own, and you have a good teacher, you can get your green belt that way. You need a project to do a green belt. So you either need a project from work or a project through a volunteer organization, or maybe a project from home, but usually craft that with whoever is teaching the class to actually give that certification. So make sure if you're going to do that and you're going to pursue it, make sure you find an accredited, reputable place, and not just, Green Belts Are Us online where you can get that. I mean, you guys all know that you can get your ticket punched a lot of ways. You can get bachelor's degrees, master's degrees, PhD degrees in no time at all, but it's from, Acme University or something that doesn't really, it's not as meaningful as an accredited organization. So I would say shop for one of those.
All right. Thank you.
Okay. So, but I'm not sharing, am I? Oh, I am sharing. Okay. I never know where this is. Okay. So we're going to jump into chapter 7 here with the time we have left. And we're going to so this again goes back to the book, chapter 7. And we're going to talk about process-based organizations. So, and if we get through all of these slides, then I think we'll be okay. And if we don't, then we'll pick them up next week. So we're processes, and I've been talking about processes since day one, right? And we haven't really defined them and we haven't really looked at them, but the process is the steps that determine how the work gets done. So they are the step-by-step kind of thing that tells us what we need to do. So if you, I got it. So the example that I use a lot is Nestle's chocolate chip cookies, right? Have you guys all made Nestle's chocolate chip cookies at some point in your life, either on your own? And this is not the cut and bake ones, not the in a tube and cut it up. So somebody said, yeah, but Professor, that's all I've ever done. And I said, well, you're missing something. So go buy a bag of Toll House chocolate chips. So if you go to the bag of the chocolate chips, on the back, it has the recipe, right? And at the top of that recipe, it'll tell you need 1 bag of Toll House chocolate chips. You need a cup of brown sugar, white sugar, butter, flour, whatever else you need, right? All of that stuff is there. So that part of the recipe is analogous to what we talk about in manufacturing as a bill of material. And it's the stuff that you need to put together in order to make whatever you're trying to make. So if I have an iPhone, my bill of material is a lot longer than those 5 or 6 things I need to make chocolate chips, right? And when you make the chocolate chips, it tells you that you can put nuts in it. That's optional. Some people put, they mix the chocolate chips, white chocolate chips and milk chocolate or dark chocolate or, whatever you want to do. So it doesn't really give you all those variations. It doesn't say you can put pecans or walnuts or whatever. And people many people have their own twist on that to add this in or subtract this or something like that, to make them chewier or crunchier or whatever, however you like your chocolate chip cookies. But that top part is what we call the bill of material. And it makes sense, right? It's all the materials that are listed. And then the bottom part is what we call the process. It tells you to, I think the first thing you do, and I haven't made these in a while, so don't quote me on this exactly, but I think the first thing it says is like put the butter and the sugar and the eggs all together, and you cream that all together. You put kind of all the wet things, right? The butter and the sugar, or the butter and the egg, and then you put the sugar with it. And then you might add in the brown sugar and mix all of that up. Because if you just put the flour and the butter and the egg and whatever, and you hit the mixer, that flour is going to go all over your kitchen, right? You guys have all done a little bit of cooking, and that flour goes everywhere, even when you're just scooping it up and putting it somewhere. So if you put the flour in a mixing bowl and turn on those beaters, that flour is just going to go everywhere. So what you want to do is get something wet, and then what you ultimately do is fold in the flour, right? I think that's the word they use. They fold it in. Typically you mix everything else with the mixer, the beaters, get it where it's wet, and then you add some flour, stir it in, add a little more flour, stir that in, and they talk about that. And then they say fold in the chocolate chips, because again, you don't put the chocolate chips in the mixer, because if you put the chocolate chips in the mixer and turn it on, what happens to the chocolate chips? What do you think would happen?
They break.
They break. Yeah. So now you guys are all going to go try this, right? And see if this really
Yeah.
works.
Actually,
So-
I want to see what happens.
Yeah. You ever put something like chocolate chips or nuts in a blender? It chops them up, right? The mixer, the beaters in the mixer will work like the blender and chop those chocolate chips up into little tiny pieces. And that's not what you want. You want the chocolate chips in your cookies, right? So you don't put those in the blender part of it. And that's the process steps. So it tells you very specifically how you do that. Step 1 is this. You put, and again, I'm paraphrasing a bit here, but step 1 is to put the butter and the sugars together and the egg, and eggs, I don't know what it is, but mix all of that up. And then you add in the flour, and maybe you can put the flour in with the mixer, but you turn the mixer, excuse me, on low, and you stir that flour in slowly. You don't just dump all the flour in, because if you have all of that butter and sugar mixture, you just dump the flour on top again and hit that mixer, it's going to go all over the place. So you have to move that in slowly. And then the folding part, that word folding, is at the chocolate chips at the end, after you get the batter all nice and set up, that cookie dough batter taste that we all like in ice cream. And then you put in the chocolate chips and you stir those in, and you don't beat that any further. So you've got all of that together. And then it tells you to get a cookie sheet and line the cookie sheet or grease the cookie sheet and drop them on there, and then bake them for half an hour at 350 or something like that. All of those things, if you break that down, and they don't break it down quite that step 1, step 2, step 3, but they do tell you how to make that. And that is the process. And that's what we're looking at for any other kind of process. What is the first thing we do? What is the next thing we do? Can we do some things at the same time? Like while the oven is heating, you can do this. While the oven is heating, you can go prepare the pan, grease the pan, and do all of that. You can warm the butter, anything like that. So if you've ever cooked, the recipe is the process. So we're doing the same thing again, whether we're making cookies or iPhones. There's a piece of this is where we start, and we put this together first. We take these 2 pieces and put them together, or these 3 pieces and put them together. And then we add on something else and add on something else and add on something else. And then we end up with an iPhone. So the process is the way the work is done, the steps that are needed to be taken, the way the work is broken down to allow that to be done in a sequence that's going to give us a finished good that is what we want. So it can be really simple, or it can be really, really complicated. How many of you have made like Rice Krispie cookies? Oh, come on, you guys. Nobody's made Rice Krispie cookies? Okay, so Rice Krispie cookies are like the easiest thing in the world to make. You got Rice Krispies, you got marshmallows, and you got butter, and you got Rice Krispie cookies. You just have to be able to measure it. You melt the butter and the marshmallows together, then you stir in the Rice Krispies, you pour it out on a flat surface like on wax paper or parchment paper, and you got cookies. So that's a very, very simple kind of thing to do. So Aggie, you're laughing, but have you ever eaten these? Do you guys know what Rice Krispie cookies are?
Yeah, I mean, I kind of thought I was thinking of Rice Krispie treats, but I guess that's
The same thing.
brand name, yeah. But yeah,
Yeah, I
just
know,
thought maybe, yeah.
I know Rice Krispies, but I was gonna say
Yeah,
I tried baking, and that was very short-lived, and then I mixed salt with sugar, and that was it.
Well, that would not do it. But that's why the Rice Krispies are great. The little boy next door, he's not so little anymore. We've lived here like his whole life. But when he was like 5, he wanted to cook, and I said, "Come over and we'll make those cookies." And he was like, "Okay." He was excited. So I had him. He had to get we had to get a little step stool so he could get to the oven, or to the top of the stove, and stir the butter and the marshmallows and make sure that all got blended together. It's one of the easiest things you can do for a kid to teach them how to cook something. And almost everybody likes those. I don't know anybody who doesn't like Rice Krispie treats or whatever you want to call them. Very simple, 3 ingredients, right? And if you guys cook at home, there's a lot of suppers like that. Here's a 3 ingredient stew or soup or something like that. You put this in the crock pot, you add a cup of water or 2 cups of water or whatever, and you're good to go. If you have a rice cooker, you put the rice in, you measure the rice, you measure the water, you turn the thing on, and you walk away, and it goes off by itself, right? So easy things. So some things are very simple processes. Other things, I mean, think about your computer. That's a pretty complex process. To put that together is pretty complex. And the bill of material is very long. So, but those 2 things together really make up all of the process, because you've got to have the the right materials that go with the steps to make that work. So we're looking at the methods, the processes, whatever you want to call it. Some things are, you know, common sense, but you can tell from looking at the recipe on the Toll House cookies on the back of the chocolate chips that it tells you things like, you know, fold in the cookie, fold in the chocolate chips. It doesn't say beat them in at high speed. And so I'm sure some people have done some things like that. So some of it's common sense, but you have to take into account who is not your audience, but who are the workers that are going to do the work. So the simpler you make it, the better your training is going to be, the easier it's going to be to train people, and the more they're going to retain it. So you really want to break it down, chunk it down into small pieces so that each step is very clear and that you've got the right tools and the right approach to do that. So you want to have people that have common sense. You want to have an open mind with those performing those steps. And then again, you want them to be standard. So you want to set up standard operating procedures that say, this is the way we do it every time. You're not allowed, this is not finger painting or, you know, whatever, where you're allowed to go in and do anything you want. This is step one, this is step two, here's step three, and this is how we're going to do that. And that's the only way you're going to get things that are repeated, are made repeatedly, repetitively, and have the same kind of standard of quality. So the components are the pieces of the work, and it's also the pieces that we use. We talk about components in terms of material, but we also talk about the step that is a component step, like cracking an egg is a component of putting the egg into the bowl. You know, it doesn't tell you crack the egg, drip that into the bowl and throw the eggshell away. And most people know that you don't throw the whole egg in and just start beating, right? That because you don't want eggshells in your food. That's kind of the common sense part of it. When you say add an egg, you don't expect people to just throw the eggshell and all into the bowl. Now, I'm sure that's happened from time to time, but that's not, if you've ever been around food, you know that the eggshell is not the edible part, whether it's cooked, the egg is cooked or raw, eggshell is not the good part. So it means peel it first, get that out of there. And nowhere does it tell you to cook that egg. So you should think that it's a raw egg, even though it doesn't probably say get 1 raw egg or 2 raw eggs, whatever the number is that it goes into that recipe. So the components have that word component has kind of a dual meaning. And then another piece of it is the time. And it like I say, when you're making cookies, it will tell you to bake it at this temperature for this much time. And if you need to bake it faster, it says maybe you're cooking something like a roast and it says leave it for 2 hours. Can you turn up the heat and make it go faster?
No.
Yeah,
I
Peter,
mean,
that was a
no.
violent no. Have you tried something like that before or been around somebody who tried that?
Yeah, my father.
What did he do?
Turn up the heat to try to make it go faster.
Yeah, that doesn't work.
No, it doesn't. We're all mad at him.
Maybe 20 degrees or 25 degrees, you could cook it a little bit faster. But most things through the trial and error process, they've said this is the right temperature. So you know, this is the right temperature and this is the right time. Now the time can vary, you know, 5 minutes or so, depending on how hot your oven is, how hot it heats up, how hot the oven was when you actually started the cooking. Did you put the things in and then turn on the oven or vice versa? But yeah, you can't really do that. And it doesn't work the other way either. You can't turn it down to 180 and expect it to get cooked in twice the time. You say, oh, I need to go do something in the yard. This says 30 minutes, but I'd like to leave it for an hour. It doesn't work like that. You got to come back in 30 minutes and pull it out and let it sit. It needs to cool. And so you have to be careful about those things. So time is an important component. And then any of the other things like temperature, cleanliness, you know, if you're using anything that's wet or electronic or whatever, you don't want any dirt and dust in there. So they do things in clean rooms because you don't want things contaminating that. If you work in a food place, they make you pull your hair back or wear a hat or something because they don't want a lot of food contaminated by people's hair falling off and things like that. So there's other pieces of that you have to look at to really flesh out your whole process. Even at school, when you use a Scantron, they tell you, don't use red ink on that. And usually I tell students, please use a pencil if you can, because if you make a mistake with black ink or blue ink, the machine might read it, but you can't erase it, right? So if you're not sure about it, don't do that. Use a pencil that's erasable. Other things, that you sign papers that tells you use blue or black ink. We probably all known somebody who likes to use some weird color of ink like green or purple or something. And those are fun colors, and I don't have a problem with people using those, but there are some legal applications where it says you can't do this. Don't sign it with a purple pen or green pen. Make sure, or a red pen. Make sure you use blue or black ink to do XYZ. So there's reasons for those. So there's different parameters and different ways that we set those processes up, whether it's, signing the lease on your apartment or your mortgage on your house, or doing something in a factory. All of those things have different steps and different requirements for each step. So the processes are key to being efficient, effective, to, excellence in quality and productivity. So efficiency we define as how. Anybody have a definition for efficiency? The way I define efficiency is being effective with fewer resources. So either less time, less material, less people, less steps, fewer steps in there. So efficiency is doing something well completely with fewer resources, whatever those resources are. And effectivity, so I should have effectivity first, because effectivity says you're accomplishing what you want to accomplish, right? You're effective, you meet your goal. So if your boss tells you, hey, you're really effective, that's a good thing. But if they tell somebody else you're really efficient, that's kind of a better thing, because they're both effective and they can do it probably faster, cheaper, easier than you. So you want to be effective, but then once you get the hang of it, you want to be efficient doing it. Excellence is just a standard that we set, and each thing we do has a different standard of excellence, whether it's related to time, to quality, to whatever, the meeting the specifications or whatever. And then productivity we measure by output over input. So we say, if we're going to measure productivity, we're going to make so many iPhones an hour, or we're going to make so many bagels an hour in the morning. So many bagels. And if we're going to look at how productive we are, we're looking at output. So output isn't sales usually. You can look at sales and say sales per day for the bagels, but you want to say, what is my output? So how many am I able to produce in an hour or in the early morning shift? And then we sell those the rest of the day, kind of thing. So output over input. And then we're trying to identify, again, how we're going to get work done. What is the process? What are the steps? What is the method that we're going to use? And then what are the assumptions or the constraints that we have, or whatever? What are the gotchas, the watch out for this, that we would also put in the process? We're looking at how to understand the activities, how to challenge those, and how to improve those. So we want to get a set of activities that we're going to use to make our products. So once you get them understood and what they're doing, how they're doing that, why they're doing that, then and only then should you start to challenge, to try to improve. Okay. And you get things like, okay, I want to cook this faster, so why can't I just turn the heat up? Well, because it doesn't work like that, right? So you might say, okay, this says 325. What if I cooked it at 350? Well, you could try that. And maybe cooking at 350 might do it a little faster, but it also might make that a little more crunchy on the outside or crisp, or a little more well done than you want it to be, depending on what it is. If it's a turkey that you're cooking this Thursday for Thanksgiving or whatever. So you want to understand it first, then it's okay to challenge it to try to improve it. What can we do a little bit better? And then what we want to look at is, how our inputs become outputs. So when we're making cookies, we've got sugar and butter and flour, and what comes out of that is cookie dough, and then that cookie dough becomes actual cookies. So how does that transformation get done? With the first piece, we took butter and sugar and whatever else, we transformed that through mixing and putting that all together into cookie dough, and then the cookie dough becomes cookies when we separate that into little pieces and we add heat to it, right? So how do we, what are the things that we do? So we're looking at defining our processes all the way through and making sure that we understand that transformation. So we're looking at what we have to do in series and what we can do in parallel. You guys know the difference? What's in series?
In series, it's like successively, one after each other.
Right. You have to do step 1 before you can do step 2. You have to do step 2 before you can do step 3. What does in parallel mean?
That you can do multiple things at the same time.
Yeah, you can do things at the same time. And so that because they don't require the same resources to complete them, or if they do, you can duplicate that. Like if it requires a table, you can duplicate that. But you can do those at the same time because they're not dependent on each other, right? They're independent steps. So I can turn the oven on while I'm mixing the cookies, but that's really the only thing that I can do in parallel, right? Is let that oven heat up while I'm mixing those cookies. I could, because I can't really do anything else to that while I'm doing that. Now, if you're baking a cake, you can, if you have 2 people or 2 different workstations, somebody can be making a cake and somebody can be making icing. Now, you don't need the icing until the cake is cooked and cooled, but you could still be making it at the same time and put it in the refrigerator or set it aside until the other is done. So you could do those in parallel. You can't really do the dishes until everything is, you can't complete the dishes. You can start doing the dishes, that clean as you go thing, right? But you can't finish the dishes until you're finished with the process, because everything, you still got things that are in use and still being dirtied or used, so that you can't be cleaned until they're finished. So what things can we do at the same time? So in series or in parallel, we're looking at the time, the people, the material, and then how much space, how much equipment we need in order to do that. So we're looking at the resources involved, and then the time and the space that we need in order to do that. We're trying to measure that and looking at, what can we measure? We measure the product itself. We measure the process step, maybe in terms of time. We measure the materials that we use in terms of either weight or volume or pieces and things. So what do we measure, and how do we define that? And then the lean philosophy says all processes can be improved. We can make wholesale processes, which may be as much as starting over and trying it again, or we can make little incremental changes or tweaks to that. Once you get a good process, you're going to tweak it. So if you're going to make chocolate chip cookies, you're probably not going to go and try to recreate that wheel, right? You're trying to make chocolate chip cookies a little better. So you might use another spice like nutmeg or cinnamon or something. You might try it, put a little more flour in to make them a little chewier, or a little more butter to make them a little more buttery or something like that. You can use some baking powder, baking soda. People who are better bakers than me tweak that recipe. But I go by what's on the, well, I go by what's on the package, maybe a little less sugar because they are pretty sweet. But a lot of people, but other recipes, I will tweak and kind of play with. Most people don't find a recipe that says, oh, that sounds good, and start with wholesale changes. They may make some incremental changes, or, I don't like, I went out to dinner last night and somebody ordered chicken piccata, and the chicken piccata had artichoke hearts. So I've made chicken piccata before. I don't use artichoke hearts. I thought it sounded like a great idea. I might do that next time I make it. And somebody else may say, no, I'm not doing that. So, is it an incremental change, something you like? If you like things hot and you're making chili, you might use extra heat in it with whatever kind of peppers, or you might not. And if you're vegetarian, you might not put any meat in it. You might use just vegetables, or something like that. So we do different things. And so we talk about these in terms of manufacturing, but there are also things that we do, like cook, and the processes that we use for cleaning, for washing dishes, for whatever it is that you do. If you need to make some changes, you can do that. We talk about process architecture, which is the framework. It's the structure that we use around the process. So what we're trying to do is look at the process like a blueprint that tells me how to do things, and it tells us how things fit together. If we can use tools and things like that to hold this piece while we put that piece, connect that piece to it, or while we screw something together to do that, that's going to help us do that. So what is the framework that we have? So are we aligned across the organization? Are we set up to do some metrics? Do we all understand that? What is our core process versus a support process? And how do these things all work together? So what is the architecture? The library tells us this is what we've done before. So anytime we make a change, that we can go back and see, what did we do before we make that change. Maybe we made because you see this sometimes where we say, okay, let's make this change. Well, we actually made that change 2 years ago. We went the other way, right? We went from this to that, and now you're suggesting we go back. So that might be the right answer, or it might be that, no, that didn't work last time, so it won't work this time. So we need a library that tells us all of that. And you need all the employees to have that, so that you're all talking the same language. Visuals are good, whether they're photos, videos, pictures, diagrams, and things like that. Any of that is good. You want a way to tell that what is good and what is not. When we talk about things like counting paint drips or scratches, oftentimes in the areas where they check products for that, there's a big board, and it says, this is acceptable, this is not. So it will tell you very clearly, a scratch this deep and this long is not acceptable, but one that's this small and this shallow could be very, very acceptable. So depending on what you're checking and how that is, if you're checking seams on clothing that is getting produced, if you're checking, signatures or anything like that, what's good, what's not, a lot of times there's boards that actually tell you that. How do we, track our costs? Failure costs come in the form of scrap, of rework, and any of those 7 and 8 wastes that we looked at a couple weeks ago. So you want to go back and refresh on what those are. But what is scrap? If we have scrap in a process, what is that?
It's a wasted material.
Right. It becomes unusable material, right? It
Yeah.
is not to be put back into the production line because it's no longer has a useful life or useful ability to be part of that final product. How does that differ from rework?
I'm assuming that this is rework is a product that it's semi-finished, that can be taken back a few steps and then brought forward in a correct manner.
That's a good way to say it, Alexander. That's really good, except that it might be finished. So you might have the finished part and you test it and you say, uh-oh, I got a problem. So then you go take it apart, find out that this is the bad part. You can take that part out, put a good part in, put it back together, and it works, right? So rework is redoing the work that you did to make it in the first place. It is definitely a waste because you don't want to do something twice. Once you put it together, you'd like to ship it and sell it, right? But if you can't do that, if you have a problem that you can fix, then you want to be able to fix that. And then that part that's not good might be the one that ends up scrap. So defects or rejects end up typically either being scrap or rework or kind of some combination of that, where you're reworking it, but you're scrapping two of the parts that aren't any good. And sometimes not everything is reworkable, right? If you're in a bakery and you're making cookies and you burn the batch of cookies, you just scrap them, right? There's nothing else you can do with them. And if one turns out kind of squirrely shaped because for whatever reason you're making round cookies and this one ends up being kind of really oval shaped or has a little tail on it or something because something dripped in the chocolate chip went the wrong place or something, that's going to be scrapped. Now that doesn't mean that somebody doesn't eat it in the bakery, so it doesn't necessarily go into the landfill or into the trash, but it has to be accounted for and it's not usable, it's not sellable. So if the defects and that are not sellable, they're not in a condition. And it doesn't mean that you can't sell some of the scrap for scrap metal or scrap plastic or whatever. You can recycle it, you can reclaim some of it, but scrap is things that are not going to go back into the original products that they were intended to go to from the beginning. And then we use this library to establish metrics and say what's working, what's not. How do we know we're making progress to our goal? Peter, did you have a question? Did you have your hand up or did I just see a shadow?
No, I'm popping my phone.
Okay. So we talk about this library model. We have everything from a big picture down to these detailed assumptions and the baseline that we started with. So we want to know what the core processes are, and then we have our maps and our steps and maybe our flow charts and some of that documentation, and then some more detail for each individual step. And then lastly, like I say, our assumptions and our baseline. So it just tells us how to build that and document that. So we talk about 6 serving men, or the 5 W's. I don't know where I got the serving men. I think that's in the book, but the 5 W's are the who, and I learned this as a kid. I don't know if you guys did, but who, what, when, where, why, and how. I don't remember where I first learned that, but we're looking at, who are the process owners, who are the customers, what is the what are we supposed to be doing with the it's usually around people involved. What level of detail? What is the activity? What is the description of what's supposed to be happening? When, of course, is related to time. Where in the production line? Where does the info reside? Like, where is my standard process? Where is my process documentation? Where are my parts? How are they housed? All those kinds of things. So it's a location thing, geography. Why is the importance, and what is it related to? And then how is the way that things get done, the verification, the review, the update. How do we know it's good? How do we know it's bad? So those are good questions to ask all the time. And the book also talks about the RACI model, which is a good model. And I've seen this in a lot of different clients as well as places that I worked. So you look at who has responsibility for things, who's accountable for that. So responsibility means who's doing the work. So if you're responsible for that, it's not just that you're overseeing it, but you're actually getting it done or making sure that it gets done. Accountability is more overseeing and approving, disapproving, but not really making it happen as to, you know, hands-on kind of thing. Consultants are, you know, key stakeholders or subject matter experts who know a lot about things and they're getting involved in things. And then who are the information, who needs to be informed, who has the need to know is what we're looking for, who has interest in this process, who has interest in the outcome, who has interest in this project that we're doing. So who has the need to know? So you can see this is an example of a RACI chart when you're looking at the planning, defining the requirements, developing our options, the final solution, and then the training for the end user. So we're saying, okay, here's Annie's job. Here's Annie, here's Bill, here's Charlie, and here's Debbie. These are our team members. And now we're going to look at who has accountability, responsibility, is a consultant, and who's just needs to be informed about these things. So it looks like if we look at the planning, this is something that Bill is going to do. Annie's got some accountability, and Charlie's might be a subject matter expert that you want to ask about this thing. When we're defining the requirements, Bill and Charlie are going to do that. And they're going to work with Annie and Debbie, who can maybe give them some advice and things. And then we get to the options. It's Bill and Charlie with Annie looking on and helping out, and so on and so forth. So it's a pretty easy chart to use. And it makes things really clear. And a lot of times you'll find out, you know, more people need to be informed that you thought, or maybe if you're, you know, responsible for it, you probably are informed. So you don't have to do a special step to inform somebody who is responsible for it. But maybe the accountability people and some of the consultants need some extra information. So these well-managed processes, when they're well managed, you've got clear ownership. Who's responsible? Who owns that process? Who's the one that's checking it, making sure it's still working, that it's producing the outputs that you want, the good things that you want? Is it customer focused? How well is it working? Is it working like you want it to? Is it stable, or is it all over the place? Do I get good, consistent results from that? Or am I kind of hit and miss? Do I need to mistake proof it? So am I getting some mistakes, and maybe mistakes that are repetitive, which is the worst thing? You know, making mistakes is what happens, but when you make the same mistakes over and over, that's not good. That means you're not really finding the root cause and putting prevention in place to keep that from happening again, because you shouldn't have the same mistake being made over and over. Can we control it? Do we have a plan in place to monitor it? Are we looking at the communication on a regular basis? Are we taking corrective actions like we need to? And again, looking for that prevention kind of thing. Or do we have processes that are clear and consistent and everybody understands them? Because if you have something that's too complicated and people don't understand, then they're not going to get it right. And then are we thinking about risks involved with across the process? So I'll tell you what, it's 9:35 by my computer, I think. And we finished chapter 7. Why don't we call that a night? Any objections to that? I guess you're not objecting, huh, Peter? Okay, so you've got your homework assignments, and the homework's due next week. If you have trouble, like I said, don't feel bad about reaching out over the holidays. I'm happy to work with you on those if you need some help. And I wish you all a very happy Thanksgiving and a very safe holiday. I don't know how many of you are traveling, but even if you're just driving to a relative's house or a friend's house, this is a weekend to be very careful and be very safe. So I will look forward to seeing all of you next week.
Thank
I have
you.
a quick question, Professor.
I will stay here as long as you have questions.
Okay. Yeah. When we do the homework, if we like do it on Excel, can we just like submit that Excel sheet basically?
Absolutely.
Okay. Cool. Thank you.
Just no Google Docs. If you do it in Google Docs, you need to save it as a PDF.
Okay.
I can't
Okay.
read, for some reason, I can't read Google Docs in Canvas because I don't have a Google account. Mike?
Yeah, I think it's usually how that is. I think with all of my other professors as well, they always just emphasize just never upload a Google Docs document as long as it's PDF though.
As
I
long
think
as
the
it's
most
PDF,
friendly. Yeah.
if it's Microsoft Office, so Word, PowerPoint, you can put it in PowerPoint too, if that's easier.
Okay.
Excel, all that I can read. I just cannot read Google Docs.
Okay.
I think it's because the Google Doc can only exist inside the Google browser. It's like a web app. And so it won't work like inside the web app of Canvas.
Yeah, that makes sense. I just know it doesn't.
Unless you
work.
have like one of those Canvas like window in window things. I forget what those are called.
I don't. So yeah, in any of those formats, if you want to cut it and paste it and put it into Word or put it into PowerPoint, any of that's fine.
Okay. Thank you.
And Google Docs saved as PDFs, those are fine too. Okay, happy Thanksgiving, everyone.